JEP 366 covers deprecation of one interesting combination which one can use to enable parallel minor garbage collection and serial major garbage collection. But before watching this video, if you are not familiar about Java garbage collection activity, I would recommend please pause this video and read some articles about JVM memory model. Or if you want me to create a video, please let me know in the comment section. This JEP revolves around serial and parallel garbage collectors. So in general, JVM heap memory, as we all know, is divided into three memory spaces. One is called the young generation, old generation, and the permanent generation. So when the object in Java initially gets created with a new keyword, it first allocated in young generation, and when the young generation gets filled up, all the dead objects or all the unreferenced objects are cleaned up and the survivor objects moved from young generation to old generation, so that application can create more objects in the young generation and application still continues to run. There will be a time, when the old generation gets filled up, and at that time Java JVM will trigger major garbage collection activity so that it can remove all the objects from the old generation. Now, as you might aware of the term stop the world now, which actually means that when any of this activity occurs, whether it's a major garbage collection activity or it's a minor garbage collection activity, all the application threads get stopped and JVM perform this collection activity. Now, since this activity reduce overall throughput and increase the latency in the application, so time by time Java folks have introduced different type of garbage collectors, and one of the important improvement over the garbage collection activity was the usage of parallel garbage collector. So which suggests that multiple threads or multiple parallel threads will participate in order to clean the garbage from the memory. So, but based on your application needs and requirement, you can configure your own needs. So let's say if you want to use multiple threads during the minor garbage collection, or you want to use a single thread for the purpose of major garbage collection activity, you can do that. So prior to Java 8, JVM by default uses a single thread to collect all the garbage. However, due to better performance and proven results from Java 8, parallel garbage collection, or parallel GC was being set as default. So if you want to know what garbage collection type your JVM is actually using, you can use Java minus XX colon plus print command line flags. This will print all the defaults your JVM is using, so we can confirm what is the actual garbage collection type we are using. So here, as I mentioned, Java 8 by default use parallel GC, so which means for both the garbage collection, whether it's a major garbage collection activity or the minor garbage collection activity, it uses multiple threads in order to clean that. Now I want to talk more little bit about this plus operator. So this plus operator means that you want if you explicitly want to enable any flag, whether it's any JVM flag, you can use plus operator to enable it. It's more like a Boolean operator. And if you want to disable it, you just need to pass minus, and you will disable it. So now coming back to the JEP 366 deprecate. So this actually talks about one interesting combination where you can use parallel GC for the young generation and single thread for the major garbage collection activity. Now this is interesting in the sense because it can cause severe issues. Let's consider what issue I'm here talking about and why Java folks have to appreciate this particular combination. So let's say in the young generation, you can allocate, for the purpose of example, you can allocate only 4 objects at a time. So allocating O4, which means object 4, JVM triggers minor garbage collection activity. Now, since based on this combination, we are using multiple threads for the minor garbage collection activity, which means that all the objects allocated and they survived, they moved into the old generation. Now, old generation is also, capable of holding only 4 objects. So major garbage collection activity will also trigger. And by the time when this activity was, in process, only 2 objects will get removed because we are using single thread here. So, but at the same time, in parallel, young generation actually allocates 4 more objects. Now, again, it's got filled up. Minor garbage collection activity will trigger. Since there is no any space available, now only these 2 objects gets being moved because they are actually survived. For the other 2 objects, you will get out of memory exception. Now, this is something which is very weird, and this is actually difficult to troubleshoot this exception, because oftentimes you will not get this exception, and in certain cases you will get this exception. So this, just to avoid this unpredictability, they are actually deprecating this behavior. So from JDK, if you are using this particular combination in the older versions of Java, and you want to move your application from older version to the JDK 14, then you will get a warning if you are using this combination. So logically, if you can think, there are 4 possibilities, or these are the 4 combinations which you can use to configure your JVM regarding the garbage collection activity. So we have already discussed this option. However, these 3 options are actually interesting. Let's see one by one. So this option suggests that we want to use parallel GC for both young generation and the old generation. So, but by default, if you will pass this argument standalone, it will enable parallel GC for both the major and the minor. So there is no need to pass this redundant flag. Other than that, you can disable parallel GC from the minor and enable parallel GC for the major garbage collection activity. But the question is why someone wants to use this combination, because theoretically and practically, if we see, minor garbage collection activity occurs frequently compared to the major garbage collection activity. So why someone wants to use single thread in order to collect garbage during the minor garbage collection activity? So there is no use of this particular combination. So I mean, why if someone wants to use? So we should not use this. Similarly, the last one is also why someone wants to use this combination, where we want to disable and use a single thread for both minor and major. Nowadays, desktop computers or home usage computers, they all support true parallelism because they all have multiple cores. So why someone wants to use this operation is the question. So in short, we are not really using any of the combination. We are only using this particular flag to configure our garbage collector, and we are indicating JVM to use parallel GC for both minor and the major. So overall, I mean, if we can see, there is no usage of this particular option. So in JEP 366, they have depreciated this option altogether. Here from JDK 9, G1 is the default garbage collector. So from JDK 9 onwards, we will see G1 as a default garbage collector, as we can see. But we can, as I mentioned, we can configure any garbage collector from the JVM arguments. So I'm using JDK 14, which by default, as I mentioned, is using G1 garbage collection. But if you want to set this combination specifically, we can pass arguments from the VM options, where we are indicating that we want to use multiple threads in case of the minor, and we want to use single thread in case of the major garbage collection activity. So as soon as we will run this program, we will get a warning message which will suggest that option use ParallelOld GC was deprecated in version 14 and will likely be removed in future releases. So it's better not to use this option. Also, as I mentioned, since we are not using any of the combination which we discussed in the previous slide, they have removed this option altogether, use ParallelOld GC. If you will pass with either plus or if you will pass either with minus, you'll get this warning message.